Here we have the program we created in the last episode, where we can roll over the circle with our mouse, and we have an animated effect on the borders, and we can drag this to a new position. I would like to show you how we can convert the circle into a rectangle. But to be able to do that, we have to rewind a little bit and go see something called Boolean, which is a data type. Let's have a look in Wikipedia. Here it talks about Boolean algebra, which is something that was developed by George Boole. That's where the name comes from, and it's almost 200 years old. In normal algebra, we work with numbers that can be negative or zero or positive, and we have different operations we can do with those numbers, like add them, subtract, multiply, or divide. The number of possible values is infinite, but when we are working with Boolean algebra, we only have two possible values. That's like having only 0 and 1, or we can also call them true and false. Let's have a look at the processing documentation here. We can see here that next to int, the integers, the float numbers, the strings, we have here something called Boolean. So let's go here and write a very small program that uses a Boolean. I'm gonna type here Boolean, and I will call my variable is summer. I'm going to type this is equal to false. So here we have our first Boolean variable. We can print this variable. I'm gonna type here print ln is summer. And if I run the program, I see down here false. As I mentioned, this variable can have only two possible values, false and true. I cannot type here numbers. If I try, it says I cannot convert from int to Boolean. Or I also cannot enter here strings. It can only have those two values, true and false. Now I will be lying because it's not summer, but I'm saying it's true. But I just want to see here the other possible value, true. The truth is we have been using Boolean expressions many times in our previous programs, but we never mentioned this word. Where did we use them? For example, on the if statement. We typed many times something like if x is less than 200, for example, then do something here. Let's make it into a working example. So I'm going to say int x is 300, and then here I'm going to print ln x is greater than 200. So now if I run the program, we see the message down here. This is because this expression here is true. X greater than 200 is true. This is a Boolean value. Let me delete these lines here at the beginning. Now I'm going to show you that we can store this expression in a Boolean variable. So I could type here Boolean x is big is x greater than 200. So this is the name of my variable, x is big. And this is either true or false. Now I could print here, print ln x is big. And I will get, oh, I missed here uppercase B. Okay, so now it's printing here true. And I can use this variable here, x is big. This is either true or false. So I can say that if this thing is true, then it's gonna print this line. And now it's printing here, x is greater than 200. Now we know that we can store in a Boolean variable the result of some comparison. And we can not only use greater than. Let's have a look at the documentation. Down here, there's several operations we can use to compare values. The easiest are greater than or less than. We can check if two numbers are equal with equal, or if they are different with exclamation mark equal. And then there are other two which are similar to greater than and less than, which are greater than or equal to. This is greater than or equal. Let's type a few examples with all of these. So I'm gonna get rid of the program here. I'm gonna type print ln 5 greater than 2. We know this operation already. It's gonna be true. If we say 5 greater than 8, then it's false. We can use the less than, so 5 less than 8. Is that true? Yes, it is. It's true. Now we can try one of the others. Less than or equal. Is 5 less than or equal to 8? It says true. The difference between this expression and only less than is obvious when we type here the same value. Is 5 less than 5? It's false. But if we use 5 less than or equal to 5, then it's true. That's the only difference. The same thing happens in the other direction. Is 5 greater than 5? Then it's false. But 5 greater than or equal to 5? And that's true. We can also check if they are equal. Type in equal equal. Then that's true. And we can check if they are different. Exclamation mark equal. And that's false. This expression will only be true if the two numbers are different. So it is true that 5 is not 453. So that was a very quick review of the relational operators. We will come back to them in the future. Now for our program, where we want to drag this rectangle around the screen, we're going to need something more. We're probably going to use just two of these relational operators, the less than and the greater than, but we're going to have to combine them. We're going to have to combine several expressions. And for that, we're going to use one of these logical operators. There are three here called or, and not. And let's just have a look at the first two for now, or and. I think this is to write some programs. Let's declare here first two Boolean variables. One is going to be I have time, and the other is going to be I have money. Now we can decide if those are true or false. So I'm going to say I have time is true, and I have money is true. Now here I'm going to say if I have money and I have time, then I will print I will buy ice cream. And otherwise, else, then I will print I can't buy ice cream. So now if I run the program, it says I will buy ice cream. The important bit here is this logical operator. This is and. Normally in English you would write and, like A and D. I think it's easy to understand the expression. If I have money and I have time, then I will buy ice cream. Now, what if I don't have time? I'm going to say I don't have time, false. Then I can't buy ice cream because I need both of them to be true. I need to have some money and I need to have time. If I make here the opposite, let's say I do have time, but I don't have money, false. Now it is true that I have time, but I don't have money. So if I run the program, it says I can't buy ice cream. And if both are false, then it's the worst case. I don't have time or money, so I can't buy ice cream. Because both have to be true. You can think of these two symbols here as an operation, like adding or subtracting or multiplying. You use these operators with numbers. For example, you can type 3 and 6, or 2 minus 6, or 3 times 7. You use here one integer number and another integer number, and it gives you as a result another integer number. Now when we are working with booleans, instead of using plus or minus or multiplying, we use these symbols here and or. This is two vertical pipes. To get these symbols, you have to press some keys on your keyboard that depend probably on the language you speak. In different countries, they have different keyboards, and to get these symbols, you have to press different keys. In my case, to get the ampersand here, I have to press Shift and the number 6. And to get these vertical pipes, I press the Alt-GR, that's the key right next to the spacebar, and the number 1. So I can have this vertical bar. So the same way we use these operations with numbers. If we are working with true and false values, we use these other operations, for example, true and false. True and false is false, as we can see in this example. The only way we can get this expression to be true is if both are true. If I have time and I have money, then the result is also true. when this is true and this is true, then the whole thing, the result is true. That's why the first line here executes. The two vertical bars represent an OR in English, same like OR. So let's write here another example using OR instead. And this is gonna be I have money or friend has money. Then I have to replace here I have money, and here is friend has money. And then we'll type here we will buy ice cream or we can't buy ice cream. Okay, so now if I run the program, I have to declare this variable here at the top. Instead of I have time, now it's friend has money. So I run the program and it says we will buy ice cream. Why? Because we both have money. Friend has money and I have money. If I type that my friend has no money, but I do, I have money, he doesn't have. If I run the program, we will still buy ice cream because one of the two has money. One of the two expressions is true. This is true and this is false. But when I type here or, then it's enough that one of the two is true. If both are false, I don't have money and my friend doesn't have money, then this is not gonna work out. So we can't buy ice cream. Because false or false is false. To make this expression true, at least one of the two or both have to be true. So now we know the basics of how to combine several logical expressions into one larger expression, which is something that we use very often in programs.